Welcome to Database Management Systems. I'm Jovita Christie, and in this video, I'm going to explain to you second normal form, which is the second step in the process of normalization. Here, we are going to discuss now the second step of the normalization process, which is 2NF. 2NF stands for second normal form, and the condition for 2NF is that the relation or the database should already be in 1NF, and there should be no partial dependencies. So at this point, you need to understand what a partial dependency is. So first of all, you also need to understand what a functional dependency is. And for that, you would have to watch a couple of videos which I have already explained. And here I'm going to explain a functional dependency, but a very brief idea. If you want to understand it better, then you can watch those videos on functional dependencies and certain calculations related to functional dependencies. Right now, I'm going to show you what a functional dependency is using this table. So this table contains course ID, semester, total students, and the course. The course ID tells you the IDs of different courses, and semester, of course, gives you the semester in which the course is being taught. And there are total number of students who are taking that particular course. And there's, of course, the name of the course. Now, a functional dependency basically is where you say course ID determines course. So when I say that the course ID 101 determines the course DB, then that's a functional dependency because 101 always comes with the course DB, or you can say DB always comes with the ID 101. So this is an example of a functional dependency. You can see in the second row also there's 101 which comes with DB. And then there is 102. 102 comes with SQL and 103 comes with only CN. So if I ask you which course has the ID 101, you'll quickly answer that it is DB because you can look at the table and say that. And if I ask you which course is 102, you'll quickly look at the table again and tell me that it is SQL. And if I ask you which course is 103, once again you can look at the table and tell me that it is CN. There is no ambiguity in this. So this is an example of a functional dependency. Now you need to understand what a partial dependency is because the condition for 2NF says that there should be no partial dependencies. So let us see. We have the second type of functional dependency known as course ID, semester determines total students and course. So as it is quite obvious from the relation, course ID is not a primary key, as you can see, because 101 is repeating. It is coming twice, and so you cannot make course ID alone a primary key. You would have to combine it with semester. And when you do so, you get a primary key which is formed by course ID and semester together, because those values are unique. For example, 101 and 1 together are coming only once, and 101 and 2 together are coming only once. So this is unique. Each combination of course ID and semester is unique. So this would be a primary key. And if you know about functional dependencies, then a primary key always determines everything else in the table. So that's why course ID and semester would determine total number of students and the course, because those are the only two columns left from this particular table. So in this case, you can say that course is being determined by course ID as well as semester. And course can also be determined by course ID on its own. So you see, although it is one table, you might be able to recognize that this table is better suited when you create two parts of it. Okay, but before we delve into that, I'm going to explain to you the problems caused by this partial dependency. You do understand what a partial dependency is, right? You have course, and then course depends on course ID as well as semester, but then course also depends partially on course ID, because just course ID is also enough for us to tell which course it is. So this is a partial dependency. So let's see what types of problems are created because of a partial dependency. This is our table, and the problems created because of the relation not being in a particular normal form are known as anomalies. And anomalies are created because of redundancy. Redundancy is duplication of data, and you can see in this table that the name of a course is duplicated. DB is coming twice. And this is just a small table, it's just a sample of a big database. But in reality, if you look at a database, it's going to contain a lot of values. The database does not simply contain a table that has just 4 columns and 4 rows. That's not it. It would contain many rows. And in this case, it contains only 4 rows, and even then there's a redundancy in the course name. Now you imagine that you have several semesters of different branches and everybody studying the same course. Then this table would be having the same course name being repeated several times in the same table. This redundancy causes problems, and these problems are known as anomalies. And the first type of anomaly is the insert anomaly. So consider the scenario where I want to insert a new course. For example, I'm going to start teaching data structures tomorrow, so let's try to insert that course inside. Now I haven't yet decided how many students will be in my class or what kind of a semester it's going to be taught in, but I know that this is a new course to be started next year, and that's why I want to add it to the table. But since I do not have information about the semester in which it is taught and the total number of students that are going to take it, I cannot really put it in the table, because if I put it, I will have to mark semester and total number of students as null. And null values in the database are often undesirable. So we do not want any null values, but because my design of the table is like this, I have to insert null values if I want to insert a new course independent of semester and total students. The second anomaly is update anomaly. So imagine that I want to change the name of a course from DB to DBMS because I find that more appropriate. So I want to change the name. So what would I be doing? Here there is only DB. And if I want to make it DBMS, then I have to make that change twice. And in a real scenario, in a real world scenario where you have so many rows, there you would have to make that same change several times, not just twice. So this is the update anomaly. That if you want to change something in the table, then because of the redundancies, you have to do that change several times in the table. The next type of anomaly is the delete anomaly. The delete anomaly is where I want to delete a particular course from this table. So let's say that, as an example, I want to delete DB from this table. Then this causes me trouble, because how can I delete DB? If I delete DB from this table, then I also lose the data that says second semester total students are 25. This data is also lost. It's possible that this is the only data for that semester and it is getting lost because I want to delete a course. So I cannot delete a course without first deleting the rest of the values, because it's all in one table. So by now, by listening to all these things, you must have already decided the solution to the problem, and By problem, I mean this particular problem. And that solution is to decompose the table. And how do we do that? We make one part where we will keep course ID and course. Now remember, in the beginning I told you the functional dependencies involved in this table, and those were course ID determines course, and course ID and semester together also determine total students and course. So in this case, because course ID determines course was the dependency that was causing the problem, I'm going to put course ID and course on one side. So it is one fragment of the table, and the second fragment of the table would contain course ID, semester, and total number of students. So if you look at these tables now there is no redundancy because the course name will never have to be repeated again. As I'm only using the course ID, I'm not using the course name in the original table at all. And also, if you take a natural join of these two partitions that I've created, you will get the original table back. And so this is definitely a lossless decomposition. So this is a lossless decomposition, and that is why it works for us. And this is what 2NF or second normal form looks like. So of course in our two tables, our dependencies are divided. Course ID and course table now contains the dependency course ID determines course. And the bottommost table where we had this original dependency it's now converted into just this because course column is gone. So you can see there is no more any partial dependency in either of these two tables, and that's why we can say that these two tables are in the second normal form. And so that was our second step in the normalization process. Our next steps are of course 3NF, BCNF, 4NF, and 5NF, and we are definitely going to go through these steps also in the upcoming videos. So please stay tuned and watch those videos also. And thank you for joining me on this one.